Hello friends, it's the NOLA Mathman back again for another math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
So after watching this video, students will be able to solve trigonometric function problems using the law of sines. So again, the concept we're looking at is trigonometric functions. The skill we're looking at is the law of sines. And with no further ado, let's get into our lesson for the day. So we start with this first problem that says find the area of triangle ABC to the nearest 10th. And so what you first want to do is label the sides that's given. Since 9 centimeters opposite angle B, we call that side B. Since 10 centimeters opposite angle C, we call that C. So there's a formula for the area of the triangle ABC that involves our sine rules. So it's going to pop up here in a second. So it would be 1/2 times side B times C times sine of angle A, which is given. It's 155 degrees. So we substitute the given quantities in. 9 centimeters for B, 10 centimeters for C, and for sine A, we will substitute 155 degrees. So you want to get your calculator out, you plug that in, and that will give you the area of triangle ABC. We should pop up here in a second. So get your calculators out. You want to get the sine 155 degrees first and then multiply by the other quantities. And we end up getting a value of 19.0 centimeters squared. It's very important you put centimeters squared because we're dealing with area. It's two-dimensional. And so area will always be your unit squared. In this case, the unit is centimeters. So we're done with our first problem. And again, we want to use the formula that's associated for area in regards to sines. So now we're going to do another problem where it says find the area of ABC to the nearest 10th. Difference is we don't have the figure, we just have the values being given. So we're doing number 6. We're given B, angle B is 93 degrees. Side C is 18 miles. And then side A is 42 miles. So again, we want to pick the area of the triangle that deals with the sine of angle B. So we will have the area of ABC. If we're using angle B, we need sides A and C, which are given. And so the area is going to be 1/2 A times C times the sine of angle B. And so the way it works is if you have an angle, the other two sides will be used in that formula for area. So we will plug those values in. 42 miles for side A. Side C is 18 miles. And then we take the sine of 93 degrees. And just like the last problem, we get our calculator out. We substitute those values. We just plug them in. Get the sine of 90 degrees and then multiply by the other quantities. And we're left with an area of 377.5 miles squared. And again, the nearest 10th is the first decimal point to the right of the decimal point. So we're done with that problem. So whether you're given a figure or not, you have the right sides and angle, you can use that area formula to solve for the area of triangle ABC. So now we're going to do a different problem where we're going to solve each triangle, round side lengths to the nearest 10th and angle measures to the nearest degree. So whatever angles and sides we're not given, we're supposed to solve for. So the first thing we could do is solve for angle B, because if we're given two angles and we know that there are three angles in a triangle, we subtract the sum of the two angles given and we find the angle that's missing. And so that's what we're doing here. So we add 72 plus 15. We subtract it from 180 because all the angles of a triangle must sum to 180 degrees. We subtract that, that will give us 180 minus 87 degrees, and angle B will equal that difference. and that will give us, again, get your calculators out, that will give us 93 degrees for angle D. So we're done there, and so we have all three angles. Now we have to solve our sides. We have side AB, which is side C because it's opposite angle C. So we need side B, and we need the side for A. So we're given C, and we need to get the other two sides. So let's see what the NOLA MATHMAN does to allow us to get those quantities. So we're missing side A, and we're missing side B. And so we're gonna get that here. So we're gonna use the law of sines to do that. So we're given angle C and side C, so that will be what we call our known sine quantities. We're gonna use that, and we're gonna put side A over side A. We have angle A, so we're gonna substitute that for the larger case A, and we're gonna do little proportions to get side A. So we will put a proportion of sine of 72 degrees over C, which is 375, will give us sine of 15 degrees over A, side A, which we're gonna solve for. So I'm gonna cross multiply. We got A times 72, sine of 72 degrees, equal to 375 times sine of 15 degrees. We divide both sides by sine 72 degrees to solve for A, and then we get a calculator out, and we will simplify 375 times sine of 15 degrees divided by 72 degrees, and that will give us the value of A. We will round that to the nearest tenth, and that will equal 102.1. And since the units are not given, we can put 102.1, and that's the length of side A. So we have one of the two sides we need to solve for. And we're going to use that same sine formula, law of sines, with C to solve for side B, using sine B over side B. So we're going to do the same thing we did to find side A. So we erase our work here. And so next we want to put sine C over side C is equal to sine B over side B. The sides are written with lowercase letters. The angles are written with the larger case letters as you're seeing. So we have here sine B over side B. So again, we substitute our values for C. We have 72 degrees in the numerator. In the denominator, we have 375 for C. We put sine of B, which is 93 degrees, and we will solve for B, and we put the denominator is sine B. So we're going to cross multiply because they're both proportions to get rid of the fractions, and we will have B times sine of 72 degrees, that will be on the left, that will equal to 375 times sine of 93 degrees. So what we do next is we will divide both sides by sine of 72 degrees, and we will solve for B. So you get your calculators, multiply 375 times sine of 93 degrees, divide by sine of 72 degrees, and you will get a value of 393.8, and that will give us the value of side B. And so now we've solved all the missing angles and sides that are given. So now we have all three angles, and we have all three side lengths, and so we're done with this problem. We circle our answer, as the NOLA MATHMAN has instructed us to do, and now we can go on to our next problem. Very good. So we use the law of sines to solve missing sides and missing angles, and that's what we will be doing for the majority of this section in regards to utilizing the law of sines. So we're done with that, and now we're going to do another problem here. Let's see what we do next. So we go to next. We're going to do number 12. In that problem, we're given two sides and one angle. We label side B opposite angle B, we label side A, which is opposite angle A. Now we know we have a known sine quantity of angle A and side A. We want to use that as our known sine. Now that we have side B, we can find angle B through using the proportion here that's being written. So we have sine 70 degrees over 109 is equal to sine B, which we're solving for, over 105, which is side B. So now we're going to cross multiply. We're going to have 109 times sine of B equals 105 times sine of 70 degrees using cross multiplying techniques. We will divide both sides by 109. That's our first step. Now, since we're solving for the angle, as we learned, we did our trig functions on an earlier video I went through. To get angle B, we have to take the inverse sine of 105 times sine of 70 degrees divided by 109. And so that's what you're about to see here at the bottom of the screen. And so we have the inverse sine of 105 times sine of 70 degrees divided by 109. So you get your calculator out, you take the inverse sine of that quantity, and you will get angle B. And so angle B is going to be equal to, what is angle B? We're waiting here. It takes a minute, so get your calculators out, plug it in, and the value should pop up very soon here. This one is a pretty complex calculation because you have to do some things, and then you have to take the inverse of that whole quantity. And so it's taking the NOLA MATHMAN a minute here to get the value. And so we end up getting 65 degrees. They say round it to the nearest degree. So angle B is 65 degrees, as you can see here at the bottom of the screen. So we have 65 degrees for angle B. Now, using the rule that the sum of the angles have to equal 180 degrees, we have two of the angles. So we can find angle C by subtracting the sum of 70 and 65 from 180 degrees. So that should be the next thing we do. So we'll see if the NOLA MATHMAN does that. But that's the next thing we can do. We can find that final missing angle that we have in this figure. Because we know the sum of all the angles of a triangle has to always be 180 degrees. Since we're given two of the angles, we just add them and subtract them from 180 degrees. So let's see what we do next. So we look for angle C. That should pop up here in a second. And as I said, let's see if the NOLA MATHMAN thinks like me. We'll take 180 degrees and we will subtract the sum of 65 degrees plus 70 degrees, as I thought. And so when we add those together, we will get 135 degrees. So 180 degrees minus 135 degrees should give us the value of angle C. And that means angle C will be what? Well, get your calculators and solve that. Looks like angle C is 45 degrees. And so that is the value of angle C. So we have angle B, we write that, which we had solved for a few minutes ago. Now we write down angle C, which is 45 degrees. And now we need side C, and we'll be done with the problem. So we're going to use the law of sines to get side C. So we can either use sine B and side B, or we can use sine A and side A because both of those are given. So it's whichever one you want to use to get side C. So let's see what we do here. See what the NOLA math. So he uses sine A. So he takes sine A over side A. And we'll set that equal to sine C over side C. So we have 3 of these quantities given. We solve for the one that's not given, which is sine C. We substitute the values in. We have sine 70 degrees over 109 equals sine of 45 degrees over side C. We want to cross multiply to get rid of the fraction terms. You have C times sine of 70 degrees equal to 109 times sine of 105. We're going to divide both sides by sine of 70 degrees, because that's the inverse. Then we will get our answer for C. So we take the quantity of 109 times sine of 45 degrees, we divide that by sine of 70, and we get a value of 82.0, which is the length of side C. So now we have solved the 3 unknown quantities in this particular triangle, and our problem is done again using the law of sines to help us. So again, we've done 2 problems that have different information given, and we've used the law of sines to solve the missing sides and missing angles. So now we have a problem that says determine whether each triangle has no solution, 1 solution, or 2 solutions. Then solve the triangle, round side lengths to the nearest tenth and angle measures to the nearest degree. So we got a different type of problem now. So they give us information. We're doing number 14 here. Angle A is 30 degrees, side A is 2, B is equal to 4. And so the first thing we have to do is determine whether the triangle has no solution. We do that by finding the height of the triangle that this would create. And so there's a formula we can use. That height is equal to B times sine of A. So we substitute those values in because they're given in the given information. And when we solve for H, we will get a value of 2. So the height is equal to H. So it says here A is equal to H. And there's a table you can use to determine, based on the value of H, if it's a 1 solution, 2 solution, or no solution. We determine that this is a 1 solution problem. So now what we're going to do is we're going to find the values of the sides and lengths that are missing. We're going to use the given information. We have side A and angle A, so that's the sine we're going to start with. We're going to set that equal to sine B over B. Since we have side B given, we can use that information to get angle B. And so that's what we're going to do. So we put sine of 30 degrees over 2 is equal to sine B over 4. So cross multiply like we've been doing, and we're going to solve for angle B. When we cross multiply, we will have 2 times sine of B is equal to 4 times sine of 30 degrees, as you can see here at the bottom. And so we will divide both sides by 2 to get rid of the 2 that's being multiplied to sine B. From there, we know in order to get the angle B, we have to get the inverse sine of the quantity of 4 times sine of 30 degrees over 2. And so you can get your calculator out, and you're going to solve for the inverse sine of 4 times sine of 30 degrees. So we're erasing this to NOLA MATHMAN so we can put that work up there. And you can see what I'm talking about. I'm going a little ahead. NOLA MATHMAN has such an expertise in this, sometimes he gets too excited. So I'm going to erase that so we have room to write. So I'm going to put here sine B is going to equal 4 times sine of 30 degrees divided by 2. And again, as I was saying, the B sine, the angle B has to be equal to the inverse sine to get B. From that, we have to take the inverse sine of the quantity of 4 times sine 30 degrees over 2. We can factor actually the 2's out. And so actually, B is going to be equal to the inverse sine of 2 times sine of 30. And you just plug that into your calculator, and you will get that answer, and you can round it to the nearest degree. And so angle B is equal to 90 degrees. So now we have angle B, we have angle A, we have side A, we have side B. So now we need side C and angle C. Now since we have two of the angles, A and B, we can use the rule that the sum is 180 degrees to get angle C. We add A and B together and subtract from 180 degrees. And that will give us the value of angle C. So I think that's what the NOLA Mathman is going to do next to get our value. Let's see what we do next. So yes, it's just like I said, we're looking for angle C. We're going to add the two angles that we're given, and we're going to subtract it from 180 degrees. That's 180 degrees minus 120 degrees. That will give us angle C's value, which is 60 degrees, which pops up there. And now all we need is side C, and so we can use the law of sines, which we've been doing. We're given both angle A and side A and angle B and side B, so we can use either one of those signs to solve for side C. So let's see what the NOLA Mathman does. Do we use angle A, side A, or do we use angle B and side B? Let's see what we do. So NOLA Mathman puts sine C over C. That's the one we're trying to solve for. And we'll set that equal to sine, let's see, A. He's going to use A over A. So if three of these are given, we substitute those in. We have sine of 60 degrees over C equals sine of 30 degrees over 2. We're going to cross multiply like we've been doing. We'll have C times sine of 30 degrees equal to 2 times sine of 60 degrees. We're going to divide both sides by the sine of 30 degrees, and we will solve for C. And so C is equal to 2 times sine of 60 degrees divided by sine of 30 degrees. We round that to the nearest tenth, and our final answer will be equal to, let's see here, get your calculators out and plug it in, and we will get a value. Takes a minute there. Y'all should be doing it as the NOLA Mathman is calculating it, and so we will get a value of, takes a minute there, and the answer should pop up here any second, and we will get a value of 3.5 for the length of side C. And so that is our answer. So we're done, and again, we've done a variety of problems where we've used the law of sines to find missing sides and angles of triangles, whether we're given a figure or we're not given a figure. By utilizing our understanding of law of sines, we can do any type of triangle problem where we need missing sides and missing angles. So we're done with this lesson. We've mastered the concept of law of sines. And so until we have another math adventure, this is the NOLA Mathman signing off. Have a blessed and prosperous day.